This is section 11.2, part E, comparing several proportions. The chi-square test for homogeneity allows us to compare the distributions of a categorical variable for any number of populations or treatments. If it allows us to reject the null hypothesis of no difference, we then want to do a follow-up analysis that examines the differences in details. Start by examining which cells in the two-way table show large deviations between the observed and the expected counts. Then look at the individual components of the observed minus the expected squared over the expected to see which term contributes most to the chi-square statistic. So earlier, we looked at the music and wine study and found significant differences among the distributions of wine purchased under each of the three musical conditions. We entered the two-way table for the study into Minitab software program and requested a chi-square test. The output appears in the figure below. Minitab repeats the two-way table of observed counts and puts the expected counts for each cell below the observed count. Finally, the software prints the 9 individual components that contributed to the chi-square statistic. So the first one was no music was playing, and we were looking at buying French, Italian, or other type of wine. And then the different types of music we're playing were none, French, or Italian. So when the French music was playing, when the no music was playing, and how many bought French wine, there was 30 who bought French wine. We expected that 34.22 of them would, and they had a chi-square contribution of 0.521. So our goal is to look at all of the chi-square contributions and see which one was the biggest contributor to our chi-square statistic. And as you can see, this 7.672 and this 6.404 are your biggest contributors to that chi-square statistic. And this would be when they bought Italian wine when French music was playing, or when they bought Italian wine when Italian music was playing. Those are the biggest contributors to that chi-square statistic. So looking at that output, we see that just 2 of those 9 components that make up the chi-square statistic contributed about 14 of the 18.28, which is almost 77%. Comparing the observed and the expected counts in these 2 cells, we see that the sales of Italian wine are much below expected when French music is playing, as well as above what is expected when Italian music is playing. We are led to a specific conclusion. Sales of Italian wine are strongly affected by Italian and French music. More advanced methods provide test and confidence intervals that make this follow-up analysis more complete. So many studies involve comparing the proportion of successes for each of several proportions or treatments. The 2-sample z-test from Chapter 10 allows us to test the null hypothesis of P1 equals P2, where P1 and P2 are the actual proportions of successes for 2 populations or treatments. The chi-square test of homogeneity allows us to test the null hypothesis that P1 equals P2 equals all of the p-values. And this null hypothesis says that there is no difference in the proportion of successes for the k populations or treatments. The alternative hypothesis would then be that at least 2 of the piece of eyes are different. Now we do need to be cautious. Many students incorrectly state the alternative hypothesis as all the proportions are different, but you need to think about it this way. The opposite of all the proportions are equal is some of the proportions are not equal. So let's take a look at an example. Cocaine addicts need cocaine to feel any pleasure, so perhaps giving them an antidepressant drug will help. A 3-year study with 72 chronic cocaine users compared an antidepressant drug with a placebo. 1/3 of the subjects were randomly assigned to receive each treatment, and here are the results. So we have 2 different antidepressant drugs, and then we have a placebo. So we need to make a graph comparing the rates of cocaine relapse for the 3 treatment types and describe what we see. So if we look at this, we are going to look at how many of them relapsed and how many of them did not relapse for each individual type of drug. So for the first type of drug, there were 24 patients, 10 of them relapsed and 14 of them did not. So we would find 10 out of the 24 is 42%, and then 14 out of the 24 is 58%. For the next drug of lithium, we would do the same thing. So for lithium, 75% relapsed and 25% did not. For those that took the placebo, 83% of them relapsed and 17% did not. So if we graph just the proportion that relapse, the bar graph below compares those proportions, and it's much smaller proportion of subjects who relapse for the first medication than for either the second or the placebo. Are the differences between the 3 groups statistically significant at a 1% level? Give appropriate evidence to support your answer. So this is going to be a 4-step problem. Remember, first we're going to start with our state, then we do plan, do, and then conclude. In the state, you need to give your null and alternative hypotheses, and you need to state your significance level. So our null hypothesis in this case is that P1 equals P2 equals P3, or that there is no difference in the relapse rate for the 3 treatments. The alternative hypothesis is that at least 2 of the piece of I's are different, or we can say there is a difference in the relapse rate for the 3 treatments. And since if you're going to use the first options on your null and alternative hypothesis, you then also need to define what piece of I is. If you use the second versions, you do not have to define that piece of I. But if we use the piece of I's in our null and alternative hypotheses, we're going to define them as piece of I is the actual proportion of chronic cocaine users, like the ones in this experiment, who would relapse under treatment I, whichever treatment that would be. And we're going to do this test at the alpha equals 0.01 level. Next is our plan. We're going to state what method we're going to use, and then we're going to check our conditions. So we should carry out a chi-square test for homogeneity if the conditions are met. So first we're going to check the random. The subjects were randomly assigned to 3 different treatment groups. Next, we're going to check the large sample size. So we will find the expected count for each group. Now, we can see where they're getting these values based on the totals. So how many total relapsed for all 3 drugs? We have 48. And then how many total relapsed, how many did not relapse would be 24. So out of the 72 people, 48 relapsed out of 72. So our expected there, find that percentage, and you would multiply it by the 24 to see how many you would expect to relapse if they were all the same, and how many you would expect to not relapse. Since all of these counts are at least 5, that large sample size has been met. And then last, we need to check for independence. This is random assignment, so that does help create our independent groups. If the experiment is conducted properly, then knowing what one subject's relapse status is gives us no information about the other, so the individual observations are independent. Next, we're going to do the calculation. Remember, you can do this calculation by hand by doing the observed minus, so this observed minus the expected squared all over the expected, plus we go to the next one, observed minus expected squared all over the expected. You would do that for all 6 of the data points, and you would get our test statistic. You would then need to find the degrees of freedom. So we do the number of rows minus 1, which would give us 2, and the number of columns minus 1, which would give us 1. So our degrees of freedom would be 2. Now you can look that up on your table C. So you would go to degrees of freedom of 2, Go across that row until you find where 10.5 would lie, and you would tell me the p-value falls between here and here. If you find this number on your calculator, you're going to see that the p-value is 0.0052. So the last thing you need to do for that one is to write your conclusion. So because the p-value of 0.0052 is less than the alpha level of 0.01, we have sufficient evidence to reject the null hypothesis and conclude that the true relapse rate for the three treatments are not all the same. What if we only want to compare two proportions? We have two ways to do this: the two sample z-tests from section 10.1 and the chi-square test for homogeneity based on a 2x2 table with a degrees of freedom of 1. In both cases, our null hypothesis would be that P1 equals P2. This hypothesis says that there is no difference in the proportion of successes for two populations or treatments. The alternative hypothesis for the chi-square test is that these two proportions are different, which we could write as P1 does not equal P2. That is, the chi-square test is equivalent to the two sample z-test with a two-sided alternative. When the conditions are met, these two tests give the same p-value. In fact, the chi-square statistic is just the square of the two sample z-test. We cannot use a chi-square test for a one-sided alternative hypothesis. So you could only do this if it's not equal to. You can't do for less than or greater than. The two sample z procedure allows us to do one-sided tests to construct confidence intervals for the difference between proportions. For that reason, we recommend the Chapter 10 method for comparing two proportions whenever you are given the choice. So let's check our understanding. Sample surveys are sensitive issues, can give different results depending on how the question is asked. A University of Wisconsin study randomly divided 2,400 respondents into three groups. All participants were asked if they had ever used cocaine. One group of 800 people were interviewed by phone, and 21% said that they had used cocaine. Another 800 people were asked the question in a one-on-one personal interview, and 25% of them said yes, they had used cocaine. And the remaining 800 were allowed to make an anonymous written response, and 28% of them said yes. Was this an experiment or an observational study? And justify your answer. This was an experiment. Each individual was exposed to a treatment that involved how they were contacted. Next, we need to make a two-way table of responses about cocaine use by how the survey was administered. So for the method of using a phone, we know what percent it is, so we can multiply the 800 by that percent, and we can see 168 of them responded yes, they had used cocaine, where 632 said no. For the personal interview, again, we know the percent that said yes, so we can take that percent of 25%, so 0.25 times the 800 people surveyed that way, and we can say 200 people said yes and 600 said no, and we can do the same thing with the written response. Are the differences between the three groups statistically significant? Give appropriate evidence to support your answer. So for this one, we will have to do the four-step problem. Remember, on the state, you need to give your null and alternative hypothesis as well as your significance level. So the null hypothesis in this case would be that there is no difference in the actual proportion who answer yes based on contact method. The alternative is that there is a difference in the actual proportion who answered yes based on that contact method, and we're going to check this at an alpha equals 0.05 significance level. Next, we need to come up with our plan. Remember, in the plan, you need to say what method you're going to use, and you need to check your three conditions. So we are going to use a chi-square test for homogeneity if the conditions are met. We do know that this is a randomized experiment. Next, we need to check the large sample size, so we need to find the expected counts for each category. And since all of these values are at least 5, then the large sample size can be used. Now remember, to do this, we would take from our table that we have previously, we would see how many people said yes, how many people said no total, and then we would see what percent that is out of everyone that was surveyed. So there was 2,400 people surveyed. How many total said yes? You would write down that number, and then you would find that as a percent. From that percent, you would then multiply it by the sample size, and there was 800 in each one. So this is how many people we would expect to say yes out of 800, and this is how many people we expect to say no if the proportions are all the same. The last thing we need to check is the independent. So due to the random assignment, these three groups of people can be viewed as independent. Also, knowing one person's response gives us no information about another person's response. Again, for the do, you can do this by hand or you can do this on the calculator. If you're going to do this by hand, you're going to do the observed minus the expected squared all over the expected. Plus, you go to the next one, observed minus expected squared over the expected. You would do this for all 6 values, and you would get a test statistic of 10.619. Now we know that there are 3 rows and there are 2 columns. So 3 minus 1 gives us 2, 2 minus 1 gives us 1, so we know our degrees of freedom would be 1. You can look this up on your table and find what values your p-value would fall between, or if you do this on the calculator, you will get a p-value of 0.0049. So if we write our conclusion, since the p-value of 0.0049 is less than our alpha level of 0.05, we reject the null hypothesis and conclude that there is convincing evidence of a difference in the proportion of people who answer yes